And we can output those estimates just like we output the means to a new data set. So we're saying the estimates, put them in this data set new, and if we printed that out, this is actually what the data set would be, and these are going to be the variable, well, actually, the variable names will be something like this in the new data set. You actually have to do a print to see what the columns are, and then something called a proc contents, which gives you the actual names for each of the variables. So these are variable names in that new data set. So if you go on to use that data set, you know what all the variable names are for doing tables or anything else you might want to do with it. Yeah, I mentioned the difference with the mixed model is you're allowing for the correlations between the repeated measurements using this repeated statement, and by using this type CS, we were saying we want the correlations between the repeated measurements on the same samples to be constant, but we can add in this rcore option, which gives us the value of those correlations, because so far we don't know what the correlation is. So this is saying this is a correlation matrix for the 6 time points, and it's saying there's a correlation of 0.6 between each of the observations on the same sample across time. However, it might be that those correlations are not constant, and that perhaps time points that are more widely separated are less correlated, or each pair of time points might have its own correlation. So there are lots of different types of correlation available in SAS that we can use. I'll just show one here, which is which stands for unstructured. So that gives us a separate correlation for each pair of time points. So if we now, using this rcore option, print out the estimated correlation matrix, you'll see that there's different correlations for each pair of time points. And you'll notice actually that these are decaying as the time points are more widely separated, the correlation is getting less. So between time point 1 and 6, the correlation is only 0.24, whereas between time point 1 and 2, it's 0.9. So it probably is quite important to allow for the fact that as time points are wider apart, the observations are less widely correlated, less highly correlated. And there are, in fact, we're using up a lot of parameters by fitting this unstructured correlation. We've got something like 15 parameters for each of the correlation coefficients. It might be adequate to have there are different types of correlation that would give these in a more banded pattern, or give you an autoregressive correlation structure where it's just constantly decaying exponentially as the time points are more widely separated. So there are other options we could put in here to give it a simpler structure than that, but which would probably also be adequate for the model. I hope that's given a feel for just how one particular method of analysis works in SAS. The others work in a kind of similar way in that there's a basic model, and then you can add in lots of options and statements to produce exactly what you want, or get out exactly what you want from the analysis, and output it to a new data set if you want to.